Let's do a quick little refresher. So say you want the exact value of sine of 11 pi over 6. First, you would probably go ahead and change it to degrees by multiplying by pi over 180, which would give you a 330-degree angle. And then you draw your angle in the coordinate plane to figure out your reference angle and use your special triangles. So 330 degrees would be down in quadrant 4, and then if you think about your reference angle between 330 and 360 up to your x-axis, that's a distance of 30 degrees. Then you'd have your sides for your 30, 60, 90 labeled, be below your x-axis, so that'd be a negative opposite side, and then sine would be opposite over hypotenuse, so negative 1/2. We're going to use sort of those ideas again today, except we are going to use some coordinate definitions of your trig functions instead of like opposite over hypotenuse. So these are like the true ones that we do first in like my trig class, and these are the reason why your right triangle ones kind of work the way they do. So like if you have a point on your terminal side of your angle, you can take its y coordinate divided by r, which is the distance to 0, 0, kind of like your hypotenuse, and that'll give you your sine value. So if you think about this one we did up here, instead, if you had a point that was labeled on the terminal side of your angle, like this one, it would have a x value of square root 3, and then a y value of negative 1. If you did y, which is negative 1, divided by r, which is just your hypotenuse length, if you think about it, or the distance from that point to 0, 0 would be 2. Then you're going to have the same y value we came up with our triangle, which is going to be negative 1/2. So they're really kind of interchangeable, but these coordinate definitions are kind of handy for a few applications. So you can always draw the triangle and do it that way. Oh, on this problem, we're going to pause for a second because I did the whole thing pretending like that was a negative 3. So we're going to just change this problem and say that's a negative 3, so I don't have to re-record my video. So say that I have an angle with negative 4, negative 3, a point on its terminal side. So if I draw that in my coordinate plane, make my terminal side go through it, and turn it into my triangle, I could just treat this like I'm used to. So labeling your xy values, your sides of your triangle as negative 3 and negative 4. And then you're going to have to find r, or your hypotenuse. So you can do a little Pythagorean theorem. That'll give you, if you square those and add them together, 25. R is always positive, so that's just going to be a positive 5. So if you want the 6 trig function values for that angle, you can either use your coordinate definitions or use the triangle you just drew. So like if you're going opposite over hypotenuse, or y over r, that would be negative 3 over 5, either way. And then cosine would be x over r, so your point for your point's x coordinates, negative 4. Your r value is 5, or you can look at your sides, adjacent over hypotenuse, and you're still going to have negative 4 over 5. If you do tangent, tangent's actually my favorite, because you could just look at the x and y coordinates for your point and just do y over x, which wouldn't require any additional work. Or you could think about your triangle and do opposite over adjacent, which is going to give you negative 3 over 4, which is negative divided by negative, so positive 3/4. Then you could just flip them all and get your reciprocal trig functions. So draw the triangle, use the coordinate definition, either works just fine. We're going to talk about this special tool called the unit circle. So the unit circle is a circle that has a radius of 1, like 1 unit. So your r values are 1 for all points on it. Basically, it's a circle that has all of your special triangles inscribed in it, and its radius is 1. So if I go back to my warm-up, I could like draw a circle that contains this 30, 60, 90 special triangle. Because its hypotenuse is 2, that means that the radius of my circle to fit it in there would have to be 2. If I labeled the point on my terminal side, that'd be square root 3, negative 1. So basically, the unit circle scales those down so that they fit inside a circle with a radius of 1. So to make this fit, I'd have to divide the hypotenuse and every other side by 2. So that would give me side lengths of 1, negative 1/2, and square root 3 over 2. And then if you think about the circle that could contain this, if I can make my notability work, that point on my circle is going to be x-coordinate square root 3 over 2, y-coordinate of negative 1/2. So I can do things like, since my radius is 1, and I know that like cosine is x over r, I can say that like cosine of that angle is just my x-coordinate, square root 3 over 2, because if I divide by 1, it's still going to be square root 3 over 2, and sine is just your y value. So it's a really handy tool if you know how to use it. So let's use it. I want sine of 150 degrees. So if you go to the point that passes through the terminal side of an angle with a 150 degree measure, you're going to have negative 3/2, 1/2. So you can always draw the triangle, like your horizontal distance would be x, negative square root 3 over 2, y value would be 1/2, and then you could do opposite over hypotenuse, which would be 1/2 over 1. Or easier is to just go, hey, sine, you know what that is? That's y over an r value of 1. So it's just y coordinate of that point is 1/2. If you want cosine of negative 225, that's not a measure that's shown on our circle. So let's just go ahead and get a coterminal angle that'll have the same trig function values. So I could go to a 135 degree angle, which would have its terminal side passing through the point with coordinates negative square root 2 over 2, square root 2 over 2. Now the easiest way is just to go, hey, cosine, you know what that is? That's x over r. So take your x coordinate, call it negative square root 2 over 2, and be done with it. Or you can draw your triangle in and go, okay, labeled it. It's my adjacent side over my hypotenuse, negative square root 2 over 2, divided by 1, negative square root 2 over 2. If you go for secant of 4 pi over 3, easiest way is to go, okay, secant is the reciprocal of cosine, so that'd be r over x. Or you could draw in your triangle and go, okay, well, if I go r over x, my adjacent side over my hypotenuse, I'm going to have 1 over negative 1/2, which is just negative 2. If I go for cosecant of pi, here's one that you can't do with a triangle, so you actually have to use your coordinate definitions. So this is cosecant, which is r over y. R is the distance to 0, 0. So to get to negative 1 from 0, 0, that's just a distance of 1. I wrote negative 1, pretend it says positive 1. But if you try and divide that by 0, you can't divide by 0. So cosecant of pi is actually undefined. Not every single trig function value is defined, and that is one of them. If you're doing tangent of negative 9 pi over 4, that's not on my unit circle, so you can either convert it to degrees and then add 360 a couple times, or you can leave it in radians and add 2 pi a couple of times. So you'll end up with that having a coterminal angle of 7 pi over 4. So if you go to 7 pi over 4 on your unit circle and get its tangent value, tangent is y over x, or you can draw it and divide your opposite side by your adjacent side. So if you do that, you have negative square root 2 over 2 divided by positive square root 2 over 2, which is really the same number but opposite signs, so negative 1. The last thing we're going to do is go backwards. So we're looking for some angles that have some specific trig function values. We are told that this angle that we're trying to find is in between pi over 2 and pi in that interval. So we are going to look in that interval and try to find some angles, there should be one, that meets that requirement. So since sine is y divided by r, we're looking for an angle that has a y-coordinate of square root 3 over 2. So if you look at those points, the only one that has that coordinate is the angle of 2 pi over 3. If you're looking for in between pi and 3 pi over 2, an angle that has a cosine value of negative 1/2, cosine is x over r. You could draw the triangles on these, but it's easier to use the coordinates. And you're looking for an angle that would have a terminal side with an x-coordinate of negative 1/2. That is the angle of 4 pi over 3. These should be in radians because they gave you the interval in radians, by the way. Tangent's a little bit harder. So we're in that same quadrant. We're looking for one where if we divide y by x, we're going to get square root of 3 over 3. So I would just kind of trial and error these. So let's try that first one that I already have underlined there. So if I do y over x and divide, which means I'll multiply by my reciprocal, I'm going to get square root of 3. Not square root 3 over 3. So that's not the right one. I better go to one that has a square root of 3 in it. So let's try 7 pi over 6. If you divide that one's y coordinate by x coordinate, then it's basically the other one upside down, and you get 1 over square root of 3, which if you rationalize it is our square root of 3 over 3, and that's it. 7 pi over 6 is your mystery angle.